All right, so in this unit, we're looking at how to use a protractor and learning about angles. So by the end of class, I want you to be able to use a protractor and answer questions related to angles. And obviously, you're going to know it when you can measure an angle, say within 2 degrees here, because sometimes on an angle, depending on if your compass is, or if your protractor is just slightly off, it might be off by like 1 or 2 degrees. So a little bit of within 2 degrees of the correct angle measurement. So first, let's look at an angle. There's 2 sides to an angle. Last unit, we talked about an angle. We said it's 2 rays with a common vertex. So they have the common endpoint right there, the vertex. And then those rays are sometimes called sides or arms. We're going to measure in degrees. And the inside, the short distance between the 2 rays, between the 2 sides, that's called the interior. And then the long way around, that'll be over 180, that's the exterior. And we're going to be using protractors today. So with the protractor, we'll talk a little bit about how to use it real quick. Every protractor has a little marking here. Sometimes it's a little hole in the center of it. Sometimes it's just a little, like a T or a cross. That's the origin. When you're measuring an angle, that origin is going to get placed onto the vertex. That's how you measure an angle. With your protractor, then you're going to take the baseline here, either side, it doesn't matter. Either side of the baseline, and you're going to line that up with one of the 2 sides of the angle. It doesn't matter which one. And then wherever the other side points to, it's going to tell you your angle. So we're going to use our protractor, and we'll talk about a couple of more key things as we're going about this, to draw a 50-degree angle. So the first side of your angle doesn't matter. Draw one side of your angle. Just get it in place. You can draw it sideways, straight up and down, or on a slant. It doesn't matter. Point on the left is going to be my vertex. And it's going to have an arrow pointing to the right because that side is supposed to be a ray. So to make sure we get 50 degrees, we're going to now line up our protractor, put the origin of the protractor on our vertex, make sure the baseline matches up with the side we drew. And now we're looking for 50 degrees. Now, if you use a little bit of common sense, you're going to avoid any issues when you're doing your angles. A 50-degree angle is an acute angle. It's going to be small. It's going to be looking something like that. A 50-degree angle will not. 50-degree angle will look like that. It will not look like that. Sure. There we go. So when you're picking which of these 50s, because there's 2 50s, there's a 50 right here, and then there's another 50 over here on the left. Well, if we do that one on the left, our angle will be looking like that, and that's not what it's supposed to look like. We know 50 degrees is kind of small, so we got to line it up. follow the 50 degrees out until the edge of your protractor, and then just put a little point there, put a little dot. Then you can move your protractor out of the way and use a straight edge to connect the vertex to that point. And now you've got a 50-degree angle. The other surefire way to make sure you're using your protractor right, if you look at where the first side of your angle is pointing, since this one's pointing to the right, we're using the 0 that it touches, which means we're on the inside numbers. You just use those to get to 50. If our side was pointing to the left, we'd be using the outside numbers because that's where 0 is. So one of your sides is always pointing to 0, and then you use either the inside or the outside based off of that. All right, we're going to draw an obtuse angle. Any obtuse angle. So everyone that tries this will be getting a different answer at the end. So, obtuse angle. If it's obtuse, it needs to be more than just straight up. It's got to go off to the left somewhere. And then we're going to measure that. Now that you've got it drawn, now we're going to measure it. So you're going to line up your protractor, put the origin on that vertex. And then you look to see, we know this is pointing to 0, so we're looking at the inside numbers. Mine's just right before 140. It's at 139 degrees. Like I said before, you can see it's pointing to two different numbers. It's pointing basically to 40 and 140. Clearly, that's not a 40-degree angle. It's obtuse. So it's got to be the 140 or 139, actually. So when we are dealing with angles, sometimes you're going to get congruent angles. We talked about this a little bit the other day with congruent line segments. We said when you have congruent line segments, you put those little tick marks on it. So if these two side lengths are congruent, you just put a little tick mark on each one. That shows that those are congruent. With angles, when these two angles are congruent, BAT and DOG, when they are congruent, you can put a little arc in the angle. And if you put the same arc on both angles, that shows that they're congruent. And since we're talking about angles, we might as well review wherever the vertex is, A, that's always going to be the letter in the middle when you name an angle. The vertex is A, so it's BAT. Or you could say TAB. That would be okay too. Same thing here. The vertex has to go in the middle, so O needs to go in the middle. It could be DOG or GOD. Either way is okay. So we're going to construct a copy of an angle. So if you've already got an angle to copy, so first thing you're going to do on the angle you are going to copy, well, first thing you're going to do is draw one side of the angle that we're going to make be our copy. We'll use your straight edge and draw one side of your angle. If you want to draw it the same way that this one starts out, that's totally fine too. I can grab a hold of it. There we go. Keep it slanted kind of the same way, that's fine. Or you can make it flat, it doesn't matter. So this point right here will be our vertex. It's basically going to match up with U. We could call it kind of like U prime. Means this side down here. Call it like T prime. Now, if you're going to copy this angle, the first thing you're going to do, once you have half of the angle drawn, is put the point of your compass on the vertex. It does not matter how far you stretch out your compass, as long as it's going to touch both sides. This needs to touch both sides of the angle that's drawn out there. That's called our reference arc. And then without adjusting your compass, you're going to move it over to where we're trying to copy and do the exact same reference arc. So now what you're going to do is you're going to take this reference arc, you're going to stretch your compass from one side of the reference arc to the other. Right there, from one side of the reference arc to the other side of the reference arc. And then we're going to move our compass over to where we're trying to copy and do the exact same thing. So keep your compass lined up, move it over to where we're copying it to, and do the exact same thing. And you can see that it intersects right there. So this blue point that I just made is kind of the same as this. I'll do it in black right here. Is that black point, which means our second side of this angle has to pass through that point. And we made a copy. You can pull out a protractor, you can measure, it should be the same, maybe off by like maybe a degree if you just messed up a little bit with where you drew it. So since these two shapes are copies of each other, they're congruent. They're congruent to each other. And since they're congruent, that means you can put those congruent arcs to show that they're congruent. That's true. So the other day we were talking about postulates. We said that postulates are just like duh statements. It's not that hard to, you could have come up with it yourself if you wanted to. So the other day it was segment addition postulate, where we said that if you take one segment plus another segment equals the whole length. With an angle, you can do the same thing. We've got a little color coding going on here. So as long as we've got a point D in the inside of an angle, in the interior, then we've got angle ABD, the green marked angle, and DBC, the purple marked angle, together will equal the whole thing. The two parts equals the whole thing. That's what this postulate says, just like segment addition. So in other words, actually symbols, what that said was when you take the green angle, the measure of angle ABD, plus the measure of angle DBC, the purple angle right here, together it adds up to equal the whole blue angle, ABC. This little M in the front just means measure. It means you're talking about degrees. That's it. All right, so we're going to use our constructions along with this angle addition postulate. We're going to put these two angles together to make one angle that's equal to the two of them added up. So the idea, just to kind of give you a visual, if you can imagine, you don't have to imagine too hard because I'm going to visualize it for you. Taking this angle and translating it down here. A little bit of rotation, a little bit of translation, and you get this bigger angle. That's what we're going to be doing. So let's start by copying angle DOG. So since we're going to copy an angle, you start with the one side. You make your reference arc on the angle you're going to copy. Then you make the same reference arc. Then you measure the opening of that angle. A little bit smaller. And then you bring that over and copy that size. And then that X tells you where to draw the other side from. So now we've got a copy of that DOG. So now what we're going to do is we're going to take angle BAT and we're going to copy it on top of this so that it puts them together as one angle. So we need another reference arc. We're going to take that same reference arc and do it where we're trying to copy it to. And we're trying to put it on top of this one, so let's go from there. Then you measure the opening. And you mark that off on that arc. Just draw that last little ray. Now you've got the angle. So if you were to measure all of this, I'll get a protractor real quick. Just to tie it all back together. If you measure this one's like 20, 23, 24 degrees maybe. Which means this should be the same because these angles are congruent. Now if we measure BAT, looks like that's 39. Which means this would be 39 here also. So angle addition postulate then says, now maybe we're going to be off by just a little bit because of the, maybe a little bit of error with what we were just, how we did it. This should be 23, this should be 39, which means the entire angle would be 23 plus 39, which would be 62 degrees. So let's check that out. Is the whole thing 62 degrees? Pretty close. It might be, maybe I'm at 63. It's pretty close to 62. I'm a little off center there. There you go, 62 degrees. So angle addition postulate just says when you add up two angles, you get the whole thing. So let's apply that right here to this question. Whole nother part of geometry, and aside from just shapes, is you're going to be applying some algebra to it. So if the measure of angle PQR is 112 degrees, let's look and see what PQR is. PQR. That's the whole thing. The whole angle right there is 112 degrees. And then we've got the two parts here, 72 degrees and 10x degrees. We're obviously going to be solving for x. But the first step to solving for x is figuring out what that angle is. How many degrees is angle SQR? How many degrees is this angle right there? So that whole angle, the entire thing, is 112 degrees. This part here is 72. That only leaves 40 degrees left over. You can set it up like a subtraction problem. So since this is 72, this is 40, 72 plus 40 equals 112. So now, since we know that that's 40 degrees, we can set up an equation. We know 10x is going to equal 40, and this is one of the easiest algebra equations in the history of math. X equals 4. That's all it asked for. It said find the value of x. X is 4. So this time we are making a bisector. We're cutting that angle in half. So you can kind of estimate, you know, it's going to go kind of straight out to the right. That's going to be the halfway for this angle. So the first thing we're going to do, it starts just like our other angle construction, the copy. You're going to make a reference arc. Just a reference arc that hits both sides. We're not copying it anywhere, so we don't need to do anything else with that reference arc. We're now just going to kind of move on to step 2. If you measure that opening, just like we did when we copy, this will always work out. So stretch your compass as wide as the opening, just like when we're copying it. But instead of now moving your compass and going somewhere to copy it, you're just going to make a half a circle. Not even half, about a third of a circle. Then without adjusting your compass, this is the key part. You cannot adjust your compass at this point. It has to be the same distance right here. We're going to move it to the other intersection and do the exact same thing. And then just like pretty much every construction, X marks the spot where you got this little cross on your two arcs. We're going to use that to draw a straight line. In this case, a ray, technically. And that ray cuts the angle in half. So since that angle is cut in half, that means we get two congruent parts. This angle is congruent to that angle. You can mark them with their congruent arcs to show that they are congruent.